All right. WLD 2370 Metallurgy Lecture number 16, the last lecture of the course. Welcome. We are all here despite the COVID. Destructive testing. Do I have to explain the difference between destructive and non-destructive testing? Destructive means you blow the part up, right? You render it not useful when you test it. The first one, which we all should know, tensile test. For some reason it's got pull test underneath it. I would assume everybody would know that, but you can't assume anything nowadays, right? It's a pull test, ripping something apart. Testing its tensile strength, right? Obviously, if you rip something apart, you're now destroyed, right? Can't use it. Oh, it's doing things for me. Oh my God. We're going to go over a little bit, I guess. Shear test. Shear strength is what? The ability to resist stresses that go perpendicular to the axis of flow. Right? Scissors. If you cut a piece of paper, is it destroyed? Well, it's small. It might not be destroyed. It's small, right? Yeah, so it's considered destructive. Guided. Bend. Test. I have your paperwork, by the way. Yeah. Where the heck have you been?
Where's that been? I missed one day. It's just.
No. It was 2.
It's your Monday.
Huh. Anyways, guided bend test is done to certified welders. If you're not a welder, you have no idea what we're talking about, so I'm going to explain it real quick. They'll weld a plate. Oh, look, there's one right here. So they weld this plate. Hopefully they go all the way through on the backside. This is pretty good. And they cut it into 4 strips. Here it is. And bend it in 4, well, 2 of them are face bends, so it's the top, 2 of them are root bends. So they bend it 2 one way, 2 the other way. They look at the cracks. If there's no cracks in it, that's how you become a certified welder. For the machinists, anyways, that don't know. If you're in the welding crew and you don't know, who's that? If you're in the welding group and you don't know what a bend test is, that's all bad. It's real bad. Extremely bad. Mac Tech, that's to be expected, right? Everybody masked up? Good. Impact test. Measures toughness. That is a Sharpie V-notch impact test is what it's called. We'll go look at that here in a little bit. We have one that's it's kind of dangerous. That's the one with the pendulum. You put the specimen down here. The pendulum is extremely heavy. Goes up and goes wham and hits it. Impact test specimen. That's it. So it's this little rectangular shaped object with a little bit of a notch in it. That's to initiate the crack. Hardness test. It's considered destructive, but you can do a hardness test on something if it fit in and not destroy the part, but it will leave a little dimple on it. So if you needed to not have a dimple, that would be the destructive part of it, I guess. Hardness test. Anybody know the two? There's two famous ones. If you're into engineering, I guess. Right there's one. Rockwell. Grinnell. That's the other one. There's a Vickers too. Grinnell. The indicator is more round. They do it a lot on castings because there's voids in castings, so they want more surface area to do the actual dimple. The way a hardness test works is you put a load on it, it puts a dimple into the metal, and then you unload it, and it gives you, on a scale, how hard it is. A number of, right there's the loads, that's a beautiful thing. Minor load plus major load equals total load. And there you can see that's the dimple it's going to leave. Most of the time a dimple isn't going to destroy a part, but they're only like this big, so you have to fit the part in there. So you probably have to cut the part depending on how big it is, I guess. A number of companies in the area have hardness testing needs. One would be like SKF, right? You can't have soft bearings, right? You can't make bearings out of aluminum, right? They wouldn't last very long. Cummins, the rings on a piston, extremely hard, right? They have a lot of hardness requirements for engines, things like that. Fillet, brake. Cook just walked in. Fillet brake test. This is done on another weld. Two main welds, groove welds, that's what I just showed you, and this is a fillet weld, so it's when two pieces come together. And to get tested on this, they do just this right here. They hit it. Well, I always thought there'd be like a some cool tool they use. I remember the first time I did it when I was an inspector. They took the weld and the guy just started beating the piss out of it with a hammer. I'm like, that's how you do that, huh? I figured they'd have some cool hydraulic press or something they put it in. And, oh, he just starts beating on it with a hammer. So when we do a lot of these, what I do is I set up the press brake out there to just roll it over. It does it real quick. And if you pass a fillet test, a fillet brake, let's see here. See how that weld broke? It's supposed to tear, or it's supposed to not break. It's supposed to fold over the actual metal. There's another one. See how there's a crack right there going through the middle of it? That there's your standard issue fail. If it tears out the material or folds over, I'm surprised they don't have a folded over one. See, that's basically what we do with the press. Put it in like that, and then put it down. Oh, good one. Anyways, you get the point. If it tears out the weld, that's bad. If it rips the base metal on the sides, that's good. So fillet brake, that's how you become certified in a fillet weld. Fatigue. Fatigue is going to be a cycle again. How long will something last? If it's getting hit like this a million times, right? And your etch. You're going to cut it, throw an acid on it. Depending on what you're doing, you're looking for microstructures, right? Crystal microstructures are the bread and butter of all metallurgy, right? can look at things like what happens when I heat it up, what happens when I cool it, what happens when I do nothing to it. You can still look at the microstructure, right? So let's review. Tensile, shear, guided bend, impact, hardness, fillets, fatigue, etch, all destructive testing. I almost said non-destructive. Non-destructive testing. The first thing you're doing for non-destructive testing, whether you're welding, machining a part, now it went over, now it indented, I don't know. Visual. You look at that thing every time you're done producing something, right? First test done on everything. Whether you know it or not, you're doing a visual test, right? Get done machining the part, you look at it, right, and you go, man, I hogged that, I left too many lines on it. Or if you're welding, you look at that and go, man, I left a lot of undercut on that, I'm gonna hide that, or redo it, or whatever. Or you do it and you go, man, it looks perfect, right? I guess a measurement could be considered a visual test, right? You're looking to see if the measurements are correct. Magnetic, particle, testing. This is done on big surfaces usually. I don't think machinists use mag particle testing for anything. Maybe they do, I don't know. Uses a magnetic yoke. Has metal filings. That was the president of the college. He saw me behind the bubble and gave me the thumbs up. Detects surface cracks. Used for surface discontinuities. A lot of these are going to be surface versus non-surface. In other words, if there's a crack down in a part, maybe you did a casting or something, and you're wondering if it has voids. Can you see down below the surface? No, right? So this one's for surface discontinuities. Man, I wish they turned the heat on in here. I'll show you what it looks like here. Oh, there's a good one. I don't know what that part is. Anybody know what that is? Looks like a block of steel, doesn't it? Well, whatever the part is. See all these cracks? Those are the magnetic particles that get in the cracks, and they show up like a red flag, right? You can see that pretty good. Here's a little cartoon of it. You got a crack, magnetic particles, they line up in the crack, magnetic field lines go through it. There we go. I was like, where the heck is this picture of the yoke? This little hideous green thing is the magnetic yoke. There's a button on it you push out, and then it makes a magnetic field. It's kind of cool because you can have like a metal part across the table, and you put the magnetic field on it, the part will come flying across the table at you. It's fun to play with. They're gonna put metal filings all over it, and the filings line up in the cracks. I haven't seen it done on a weld yet. Let's see, there's one, an adjustable one, so you can adjust it, and that's just a flat plate, it looks like. Bunch more cartoons. There they're doing it on a T, on a pipe. Look at that crack. It's a big one. There's a bad weld, right? Crack going right down the middle of it. I won't mention who welded that. I don't even know. Just joking. That was funny. You were supposed to laugh. Nobody laughed. I'm moving on to radiograph. What's a radiograph? Also known as? Nobody wants to hang their neck out? If you're wrong, you'll just be wrong. It's okay to be wrong. Somebody quick, say X-ray. X-ray, all right. Now you're alive. This is where it really gets down to brass tacks, right? You can't, they're gonna find a void if they got an X-ray, right? Or radiograph. Used for subsurface discontinuities. I think that's how you spell it. Look at that. Ah, you prick. There we go. Subsurface discontinuities. Did I do that in the last one? Nope. Look at that, new. So if you have a void deep in a part, this will detect it. So that's where you're talking about your castings, if there's an air pocket or cracks because you're doing a really thick section, or radiograph. Look at that, it knows. Feel the force field. Metal, let's try that. You have to be certified to do this. So you can be a certified radiographer. They make good money. Usually it's a company, they'll have one person that does it, they'll get them certified, and then that's just what they do. We need a radiograph done. Okay, you go do it, right? So right there's a good one. This is weld inspections. See all that porosity? Subsurface crack. There's one of somebody's brain. Tungsten. Tungsten inclusions happen when you're doing TIG welding. There we go. And you can see they show up like a red flag. Can't miss them. Those are all radiographs. But there's a big crack right at the bottom of that weld. Another, that's lack of penetration. Porosity there. Wow, this worked out well. See, tungsten inclusions show up as bright white specks. It's from welders dipping their tungsten in while they're doing it. Slag inclusions are black, cracks, porosity. You can't hide anything if you're getting radiographed, right? Subsurface discontinuities. Ultrasonic testing. That is sound waves. They do it for a lot of stuff, right? If you're expecting a unborn child, they get ultrasonics, right? And they can do really gross, creepy things with it now. Trust me, I know. you shouldn't be able to see what your kid looks like before it's born, right? They can do that now. Watch this. I can't, there's a word for it, I can't remember what it is. Ultrasonic. Ultrasound is what they call it, I guess. Sound pictures, there we go. Like, the ultrasounds, like when I was a baby, you can't even tell what it is. Oh yeah, look right there's the head. I don't know what you're looking at, it's a big blur, right? That's not how it is anymore. See that? You can tell that's a baby, right? There's 3D ones, that's what it's called. Watch this. Boom.
That's fucking crazy.
That's when you're like just about to give birth, they do a 3D ultrasound, and that's just sound waves coming back through somebody's stomach.
Are we in metallurgy?
We're in everything, pal. It's the same thing when they're looking for defects. These things, the sound waves come back, and then they picture, they can tell how deep something is, like the crack, they can do measurements, things like that, all kinds of stuff. Are you grossed out by that? Is that what's going on here? Okay. You need a gel, right? So they put the probe, or it's called a transducer, and they put it on your stomach, but they put a gel on first. If they don't, I think it burns, because I had, they do it for injuries too, right? If you pull a hamstring, they put gel on your leg, and then they do deep tissue heating, so that the sound waves go into your muscle and come back, and it provides warming. I used to have it done every day. And they had an intern one day that didn't put the gel on, and it burned my leg. And I yelled, "What happened? You didn't put the gel on." Don't not put the gel on, okay? You have to do the same thing when you're testing metals. They put the gel on the metal. So, we have an ultrasonics tester out there, and they gave us like five gallon buckets of that gel. Like, you don't need that much. I don't know how you'd ever use five gallon buckets of gel, but it's extremely slippery, and I've been thinking of a strategic place to put it in the winter to have some fun, and I haven't thought of anything yet. So if you can come up with something.
On the ramp going into the shop.
I'm just saying, I'm thinking more of the car or something, I don't know. There's gotta be something we can do with this.
25 gallons of stuff.
I got tons of it. It's got
Go
handles
a
on
long
it.
ways out front on the road.
Right at the intersection.
Yeah, maybe we can kill somebody, yeah. But you gotta have the gel on, or else it doesn't work right. Then you have a transducer. The probe for that is, hold on, let's get through these, then we'll look it up. Use high frequency. There's also an ultrasonic welding process that's done a lot on plastics. They use sound waves to actually melt stuff together. If you've ever gotten a plastic G.I. Joe, and it's in that plastic case where it's got the seam all the way around it, and then you've almost slit your wrist trying to get it open, that is ultrasonics plastic welding. They're using sound waves to actually get it to fuse. Everybody's opened one of those, right?
Why are they so hard to open?
It is impossible to get them open easily. And this is subsurface as well. So as of right now, we have two subsurface processes, right? One is X-ray radiograph, the other one's ultrasonic testing. Let's look up. Ultrasonic. There it is. This thing right here is what you're looking at, and you see how it looks like a lie detector test. It goes like this. As those, if you're just trying to like measure the depth of this table or something, It goes to the edge of the table and then comes back in a very consistent line. If there's a crack in the middle, it goes, and then goes past the crack. That's kind of how it works. Where is ultrasonic testing? Whoops. That. This is a big one. I want to see a real one. There's a real one. We have that exact one. It's about that big around. That's kind of a big one. We have bigger ones too, but the one you want that works the best, if it ever shows up here, there's a little one. So you take that, you get the gel down, you slide it over the part, and then sound waves are going down, and they can measure depths too. You can measure a material by how far that's going down. You have to get it calibrated right off the bat. So there's calibration blocks in them, so you calibrate it, and then you go and you can take measurements. Here's a bunch of them. Those are all transducers. So the cord plugs in right here, here, and here, and it does its thing. Couplant, that's the gel. So they can do measurements as well. You have to be certified to do that as well. So if you're keeping track of the score on certifications, so far you could be a certified welding inspector, you could be a radiographing, you could be ultrasonic. I was gonna say, where's dye? Dye's next. We'll hop into that, huh? Dye penetrant can be done with machinists, with welders, with just about anything. If you get the dye on your hands, it will never come off. For the rest of your life, you will have dyed hands. Always wear your gloves when you're doing this. It's called dye pen. It's getting into cracks. You know how many cracks are on your hands? It's like that, what's the machinist stuff, the blue stuff, what's that called? The layout stuff. Don't get that on your hands.
That comes off.
Dye penetrant. It's got a cleaner. It's got a dye. It's got a developer.
If you got a cleaner, then it needs to come off.
No, you clean the part first. It looks like you're about to tag a bridge. It's all little paint cans. Usually they have them in a kit with a little case. We got here and they had they brought from across the street, I want to say, hundreds of those cans from like the 80s, and none of them worked. They were all jammed. So one day I was spraying it in the garbage can trying to get it to work, and it's a really dark red substance that comes out, and this kid came running and said, somebody cut their head off or something, there's blood all over the place in there. It was just a dye pen, so I'll never forget that as long as I live. This kid he thought somebody had cut themselves really badly, and it was just me spraying the stuff in the garbage can. It never worked right though. Detects. Cracks. Really good at cracks and porosity. Really good at porosity. And other surface defects. What else could there be? So look up the tools for this. It's pretty simple. But yes, you have to be certified for this too. This is probably the easiest one to get certified in. There's your tools. Look, there's the kit. $155. I don't know why there's 4 cans, but should be 3 right here. Oh no, I thought it would blow it up. Let's see where it takes us. Oh, MSC, they want you to buy it now. That says cleaner remover, penetrant, developer. So the process, you put your cleaner on, you clean the material, you put your penetrant on, You wipe that off, then you put your developer on. So what happens here, let's see, don't go anywhere, thank you. Surface breaking discontinuity, there it is. Application of penetrant, right? Removal of penetrant. Guess what stays in the crack? The penetrant, right? You put the developer on and then it bleeds out. There's one with just the penetrant on, so that's the penetrant's been sprayed on there. See what I mean? It looks like blood. Yeah. I'm trying to find, there's one. So they put the developer on and then the red bleeds back out into the developer. And it's pretty obvious when you have a crack, you know. So look at this. This looks like a dye penetrant inspection of some kind of giant pipe that was produced. And you can see all kinds of cracks, porosity. Those are huge things of porosity. You gotta remember, if you have a pinhole, it will bleed out really red. So if you have something like that, that's like a hole probably like 1/8 of an inch in diameter. Here's another dye pen. We got cracks. I don't know what the heck this is. See what the part is? It does not. There's a crack on flaw check cleaner. So they're trying to sell the cleaner here. They're not telling what the part is, but you can see that's a giant crack right. That looks like the kiln that we welded at ESAB. But they'll do it on all kinds of parts. Throw a dye pen on there. I was just at a company that was doing a dye pen. I can't remember what was that. Oh, we had the part was getting rejected based off of an inspector at the customer, and they were claiming that there was lack of fusion on a weld. And they said, we think it's fused. And I said, the only way to do it is you have to put a dye pen on it. That's what it was. And they ended up not doing that, but and it's probably because they didn't have anybody that was certified to do it. Measurement machines. This is how machinists do testing on parts, basically. First one is we were talking about last class, your CMM, which stands for, and if you're in the machinist program, you should really know what this means. Coordinate, measurement, machine. When I see you guys walking around, I'm going to ask you every time, what's CMM stand for? Coordinate, measurement, machine. Has a little probe. Well, it doesn't have to be a little probe, I guess, but the one we have is a little probe because it's only, the table's about that big, square. Takes really fine measurements of parts, okay? Let's see what it has. There they are. See, that thing is about that big. Very small. That ball comes down, if it was measuring, let's say this plastic COVID certified protection device needed to be measured. That probe's gonna come down, they're gonna run it over here, it's gonna touch it, and it's gonna go beep, and then it's gonna run over here, and go beep, and it's gonna give you that exact dimension to a very high tolerance. So if you're producing parts that have a high tolerance, welders don't have a high tolerance. They're like a 16th, right? In the machinist world, that's like a mile. It's like being a carpenter. I'm off an inch, just throw some trim up. Right? Carpentry tolerance is like a mile. It's off an inch, I'll just throw some trim up, right? Welding is like a 16th of an inch, right? Which to a carpenter is really tight. To a machinist, that's sloppy, right? These machines ensure the machinist tolerances. Machinists speak in thousandths, right? It's really annoying for a welder to talk to a machinist because they're going to say, we're going to take 50 off. And you're like, 50? What the hell does that mean? They're talking 50 thousandths. Everything they say is in the thousands. Am I right? Right? Welders speak in fractions. Take a 16th off. So you got to kind of, you'll see if you interact with machinists, and if machinists interact with welders, that's just the way it is. Welders talk in fractions, machinists talk in thousands. That's what they're measuring with this. The machine, let's see if they have they come in all kinds of sizes too. So if you have parts that are huge, you got to have a huge CMM machine. So like Rand down the road, they have a lathe that's like the size of a school bus. Like you can walk inside the lathe. They used to anyways, I don't know if they still have it. But they were producing really big parts, so they had a really big CMM machine. Like you can put my Metro in it. Not that the Metro's big, but it's bigger than most parts, right? Most of them are like tabletop size. You can see, there's a person. I was like, let's find somebody that's in it to give it a scale. That's the most of them are like about that big. But if you do big parts, you got to have a big CMM machine to ensure quality. Optical, comparator. Okay. Obviously didn't spell that right. You didn't know. Sounds made up, right? Sounds like something out of the old Star Wars. Getting the optical comparator. It does. Let's ask the machinist. What does that do? Anybody know? Totally ignoring me? Sweet. Small stuff. What is the definition of stuff? That's anything, right? This is another, if you're machining a part and you have to do a really, well, if the part's really small and you need a measurement, they're going to put it in an optical comparator, and that's going to have a round scale on it that has really small measurements. I put a dime in it once when I was doing tours, so it would blow up the president on the dime. And I was a group of like 20 high school teachers, and I had the dime on there, and I said, I don't even know who that president is. Who's the president on the dime? And everybody just looked at each other. None of them knew, and they were all high school teachers. And they were like, right? So my question to you is, don't look it up either. Who is on the dime?
I don't think it's a president.
Franklin D. Roosevelt.
That's it. Nobody knew. Did anybody know that besides Tyler? You knew it? Yeah, I thought that was pretty funny because nobody knew. Then I went around and I asked people all day. Nobody knew. That's impressive. FDR. I bet all those teachers went home and looked that up though. There it is. Looking for ours, I don't see it. Ours is a Starrett, believe it or not. Starrett makes measuring devices. If you buy a Starrett, it costs $1 bazillion. Because they're good. There's a Starrett. It's not ours though. Looks a little older. Anyways, we don't have to have ours. There's a great picture. So whatever they're measuring as a gear, obviously, is in this little vise right here. That vise is about that wide. So what they do is they put the part in here, it blows it up on this screen right here, and then depending on how you want to measure it, they have clear, circular, transparent measurement things they put on there, they clip them in, and then you can take the measurements because there's lines that go all the way around it. So you can see right here, they're doing the pitch of threads. Actually, I don't know if they're doing the pitch, but they're measuring threads. Something on the threads. Could be the pitch. I don't know what that thing is. Again, threads. I don't know, whatever that is. We'll go look at ours here in a minute. Optical comparator, Starrett. stare it. Let's go shopping. These are little ones. We need a big one. Used. There's 18 grand. Those are smaller than the ones that we have. Those are all smaller, but you can see that one kind of looks like it, but so 15, 16 grand. They're expensive. Not hugely expensive, but they're expensive. Well, I'm out of notes. What do I do now? I ran out of notes. Last test. Monday. Dun dun dun. Last test Monday. Let's go ahead and italicize that. Let's underline it. Let's max it out. Ooh. And then you're done for tests for the semester.
Can you go back to the